Good morning, good afternoon, and good evening to all of our viewers worldwide viewing us live today or in the future from our archive. This event is brought to you by iMicronews, and you are part of a virtual crowd of 250 people. Before we start, there are a few logistics items. We have 3 speakers today, and we plan to run 60 minutes with a hard stop at the top of the hour. We've planned about 50 minutes in presentation, including several videos, and 10 minutes of Q&A at the end. In 24 hours, this presentation in its entirety will be available in our archive. If you have a colleague who might be interested, please tell them where they can find it. Live viewers can submit questions in the box at the bottom left of your screen. Technical difficulty questions will be handled immediately by our technical staff. Presentation questions submitted during the show will be handled at the end of the presentation, and we'll get to as many of them as we can today. You can enlarge your presentation via the enlarge button, and there is additional information available via the buttons at the bottom of your screen. Our presentation today is brought to you by Movea, and it is about enabling motion solutions for consumer electronics. Today, we're going to cover, we'll have 3 speakers, and we're going to cover market trends covered by Jean-Christophe Edouard of Yole Development. And then the main presentation will be by the Movea speakers, and they're going to walk us through how MotionIC fits with the market trends. We'll get inside the technology with a lot of highlights of the features and functions, and we'll learn how Movea works with their customers to define the needs and solutions. And then we'll have a conclusion, and we'll jump to the questions. So our first speaker today is Jean-Christophe Edouard, CEO of Yole Development. Jean-Christophe?
Thank you. Thank you for the introduction. So I will present you these few slides concerning the evolution of the market. So MEMS accelerometer, magnetometer, and gyroscopes are clearly moving fast in terms of growth. So it's linked to automotive business, it's linked to medical, industrial, defense, and aerospace. But as you can see in the slides, the area where the rate of adoption of accelerometers, gyroscopes, and magnetometers is really the fastest is linked to consumer electronics. So it seems quite long time for accelerometer, and gyros and magnetometers since now 2 years have very strong momentum and very high growth linked to this business. So we are talking about almost 10% growth for accelerometer in the next 5 years, close to 30% for main gyroscopes, and more than 30% for magnetometer. The thing to that, there is big changes in these motion sensing and the integration of that kind of devices in consumer electronics. First 3 major technical trends are already here and have to be solved by all the players of the industry and of this supply chain and value chain. The size reduction, linked to the price pressure, the device has to reduce in terms of size, and also in order to be able to fit with mobile phone applications and mobile application in general. Low power operation is, of course, a must, and more and more, because of the function needed at the system level, complex processing at the sensor level has to be implemented in order to be able to deliver function and complex function in terms of motion recognition and motion sensing. And so we see big changes at the packaging level. We see also a lot of changes at the software level. And more, the supply chain is changed and adapted in order to take into account the data fusion and the software, which are really key because we are moving from a single device with multiple axes to multiple devices and multiple axes of detections. That means the combo. And the slide is showing the growth we are expecting in the next 5 years of the combo, which will become rapidly a $1 billion market for 2015. And so, market is changing, business is changing, and the new players are entering, and Movea is a key example of new players which are here to help integration of motion sensing and bring value and functions to the companies involved in this field.
Thanks a lot, JC. And that is indeed it. Movea is a specialist in motion intelligence, and they really have made a big play into this space of device-agnostic solutions that bring the functionality of the MEMS devices to the consumer device. First up to tell us about the technology is Bruno Flamand. He's the CTO of Movea, and he has years of experience in multi-sensor and autonomous microsystems, and he's leading the way in this. Bruno, tell us about the technology.
Okay, thank you. So in this first part, let's understand how Movea builds its position into the value chain. So here's the value chain for bringing motion-enabled products to the consumer market. On the right of the slide, the end user's requirements are faced by system integrators. So as stated by Jean-Christophe, the market trend is characterized by 4 parameters. So this is increasing quantities, cost pressure, and together with higher motion performances requirements, and also low time to market. So in this trend, on the left side of the value chain, the component suppliers play a major role in providing the cost and quantities answers. And at the same time, their technological offering has grown in power so that we have more sensors and more new sensors every year. Combo sensors, we have more modalities, that is accelerometers, gyro, magnetometers, and more computing power. So that this also automatically leads to a growing complexity of the available motion component toolbox. So this brings a new era of problem solving that relies on extensive signal processing, and that creates a gap between this more powerful but more complex motion component toolbox and the market needs. So complexity and time to market becomes an even bigger issue for the system integrators. So it is our goal at Movea to provide answers for system integrators. With our technical expertise in maths, physics, signal processing, sensor know-how, and in software integration, we put the MEMS and motion component machinery at the service of market needs, therefore solving the complexity and time to market issue. So this is what we call our MotionIC offering. So at Movea, the MotionIC offering is composed of 3 main building blocks. There is the hardware set, which is chip or chipset, including sensors and microcontroller loaded with the Smart Motion firmware library. Software, as the motion features architecture is also very frequently implemented on an OS-based system, like for set-top boxes, mobile phones, and so on. And IP. At Movea, we grow through licensing and on growth a patent portfolio to protect our solutions and put it at the service of our customers. So these 3 building blocks can be combined in any way to best fit our customer needs, so that the result for the customer is easy integration, no maths, no physics, no hassle for power management, OS management, quick launch, as the MotionIC is an easy-to-scale turnkey solution that relies on components that can be scaled easily, and best-of-class IP. So the markets we pursue. The markets we are qualified on are quite numerous, as we are specialists for human motion, which applies for many markets. Movea targets the consumer markets with an offering for man-to-machine motion-based interface for multimedia, computer peripherals, also for set-top boxes and IPTV. Sports and fitness, together with physical activity monitoring, also form a continuum of technical commonalities. For sports, the end user wants to get feedback on his performance, be coached to improve, and practice happily and safely. Physical activity monitoring, it ranges from application where the end user wishes to stay fit through a monitoring of his daily life activities up to full-blown physical rehabilitation. Gaming, it has started the awareness for consumer for motion-sensitive devices, so are also in the center of smart motion feature development. Mobile phones and navigation platforms are equipped with set-up motion sensors and are OS ready, so that they can benefit from our software solutions. For Movea, there is an added value to benefit from one market's experience and bring it to the other market. So in this part 2, we will guide you through our motion feature database. But first, let's understand how we can measure motion and why sensor and information fusion is necessary. So by essence, motion is defined by 6 degrees of freedom, as an object position is completely defined by 3 angles and 3 translations for each time step. So not every motion feature will require this 6 degrees of freedom, as some rely on statistical behavior on calibrated sensor data. But let's focus on this for this slide. So we need this parameter in the world's frame of reference. Every other parameter like speed, acceleration, trajectory, angular velocity can be derived from these 6 base parameters. So how can we measure those where here we don't want cameras or any artificial source fixed to the world frame and keep a reduced cost? In this quest for information, we should take into account 2 natural phenomena. We live in a gravity field named G on the slide and in a magnetic field H on this slide, which are free to use and give us references in the world frame. So we will shortly see how we can take advantage of these 2 H and G fields. So what's inside our motion sensor toolbox? We set aside the computing power, OS-based systems, or microcontrollers for the time being, and focus on the sensors. So a 3-axis gyro can be put on the object we'd like to track. We get a 3-axis information on rotation speeds in the object's frame of reference. If we somehow know the absolute orientation at some time, we can get the orientation with this gyro sensor through integration of the rotation speeds. We'll be very sensitive to the bias and drift of this gyrometer, and on the power side, this sensor is power hungry. So let's go to the accelerometer. A 3-axis accelerometer is the way to get information related to acceleration of the object in the object's frame of reference. However, the acceleration experienced by the sensor will mix 2 contributions, the gravity field and the acceleration derived from the object's trajectory, and there is no way to separate them at the sensor level. So that in a steady or quasi-static position, the object does not experience any measurable acceleration from motion, so only measures the gravity field, therefore providing an information related to 2 out of the 3 of the absolute angles we need. In a moving situation, we will also add to the measurements the acceleration derived from the trajectory of the object. Overall, this accelerometer has a very good ranking in our sensor toolbox, for it is cheap and low power, but we are very far from a position. We have to cope with this acceleration mixture, and we suffer from the fact that the position is a double integration from acceleration, therefore we'll have to cope with bias and drift. And then the third one, the magnetometer, is less famous compared to the 3G, the gyros, and the 3A, this is the acceleration sensors. We, however, all know that the heading of an object can be obtained by such a sensor. It senses the second natural field, the first one being gravity. So this is the Earth's magnetic field. On almost every position on the planet, this field has a different orientation than the gravity field, therefore giving us access to 2 angles of the object in a world's frame of reference. So that this sensor, that we name 3M, 3-axis magnetometer, plus